Let's stop the application. That's what the developer will see while they're debugging their application if they were to run across this issue while they're building the application. But what if we were to build a release version of the application by changing the solution configuration and then selecting build solution? Now we're going to go out to our projects directory, and I'm going to act like an end user and actually attempt to use this application outside of Visual Studio, so outside of the debugging environment, just to see what the end user would see if they ran into this exception at runtime. The name of this is handling exceptions. All right, there you go. And let's go into the bin directory, into the release folder, and I'm going to double click the handling exception, and whoops. Notice that I get this ugly little message here, and it's trying to help me figure out what happened, and I get all this text here with all this ugly information, just spewing out all this information that an end user probably would have absolutely no idea what the issue was, although we can read here near the very top that the problem is that it couldn't find the file lesson22/example with no e.txt. Now, a very observant user might be able to look at this and figure it out if they stared at it for a while, but most users are going to be scared off by this, and I don't blame them. So we ideally would like to make sure that the end user never sees anything like that whenever they run our application. So again, Windows will then close the application, notify you if there is a solution available. There's just a mess going on there, and we want to protect our end users from this mess, from ever seeing this. So what we can do is actually wrap a try statement, a try and a catch around this. So we'll do this, and there's a couple different ways to go about it. I'm just going to take the easiest approach to begin with. And what I might do is just go ahead and let's switch back to the debug configuration and run the application. Now, you may have noticed that the application ran briefly and then went away. And the reason it did was because we ran this, we hit an exception here, the catch statement kicked in, there's nothing defined in the catch statement, and we continued on. What if we were to move this to right there? We would at least see the application now run for a little bit, and we would see no output. So still not an ideal situation, but at least we're not seeing any exceptions. Let's go one more step with this and say let's actually catch the exception that occurred. So here we're going to catch an exception call that we're going to call EX. Now, exception is the most general type of exception that can be thrown. What we're going to look at in a few moments are very specific versions of exceptions, but this is the most general version so that at least we can see what the problem is, and we might do something like, you know, there was a problem, something like that, and even we could provide a description of the problem, so the message from the exception. So let's go and run the application, and at least this time, you know, at least we're giving the user some feedback here. There was a problem, could not find the file lesson22/example.txt. Okay, so that's better. Again, it would require an observant and slightly more technical end user to be able to resolve this issue on their own, to say, wait a second, I wonder if that file might be named something different here on my own hard drive, as they traverse through and look for the file, and they're like, oh, I see what the problem is. There's no E on the end of example. All right, that's asking a lot of your end user, but that at least is a step in the right direction. At least we're giving them some clue as to what the issue is. Now, really what I would like to do is account for all the possibilities and be a little bit more specific. So if I were to hover my mouse cursor over this read all text where the issue seems to be mostly, you'll see that we've only been looking at the return value and the input parameters for a call to a method. But notice below that there's a list of possible exceptions that could occur. Also, if we were to go to system.io.file.readAll text, so let me just copy this, pop open, and let's go to Bing. We're basically going to be searching through Bing here for system.io.file.readAll text. That should help us find an article in MSDN that has a full description of this method. You'll see that there's two overloaded versions. We're using this first overloaded version of it. And then if we were to scroll down and past some of the initial information, there's a list of exceptions. And it would provide us some scenarios why that particular exception might happen. Like a security exception, the caller doesn't have the required permission. All right. The path is in an invalid format. Interesting. File not found. The file in the path was not found. And there's also a directory not found. Interesting. Okay, so maybe the path was too long, or maybe we provided a null value. So there's a lot of things that could potentially go wrong whenever calling this method. And as developers, we really need to the extent that we can, account for all those potential situations, at least the ones that make sense. So, for example, I could rewrite this code example to begin catching some of those specific examples. So, for example, let's take a look here. Let's first of all make sure that the directory exists, and then if it does exist, then we'll check to make sure the file exists. And so then if the file and the directory exists but we're still getting exception, then maybe we let it drop off to this most generalized exception here. So I'm going to start from the most specific case and then work my way to the most general case. In this case, I think the file not found exception is probably the most specific of the ones that we're going to work with, and then we'll catch the directory not found exception, and then if that doesn't work, we'll just print out whatever the exception was. So here I might do something like console.writeLine and say there was a problem. And then give it a specific, make sure the name is, name of the file is named correctly. Should be example.txt, all right. And then we can do something similar here and say there was a problem, make sure that the name of the directory the directory. Make sure the file, make sure the directory C:/lesson 22 exists. All right, something like that. And remember, we're getting the red squiggly. Why? Well, because we either need to add another backslash here or add the @ symbol there. Remember that from earlier? Okay. So let's go ahead and test our application, and I'm going to set a breakpoint here whenever we hit this line of code so that we can watch this execute. All right, so let's go ahead and step over, and it looks like it found the file not found exception, and so we will see there was a problem. Make sure the name of the file is named correctly. All right. Then let's go out and let's rename this to lesson 22A, and I think we're still going to get the same actually exceptions. So maybe that's oh no, we did get the directory not found exception. Good. Okay. So in this case, we'll see that error message. Make sure the directory lesson 22 exists. All right. And then for any other exception, maybe there's a permissions issue on the computer. Maybe there's the file is corrupt somehow and we can't read from it. We would get this last catch-all where we catch just the general exception and print it to the user, okay? So at any rate, the key to this is that we check the most specific exceptions first and the most general or generic exceptions last. There's also one other item I want to add here, and that's a finally statement, and this is where we would write any code to finalize, which might mean setting objects to null, closing database connections. All right, but this code is going to run no matter what, and so we're just going to go console.writeLine, closing application now, like so that we can see that this code will run regardless. It's just that one last chance as a developer to clean up our mess before we stop the execution of the application. So, and you can see that now represented here by closing the application now. Great. Now you might look at this and you might think to yourself, okay, great, I'm going to use this try-catch around everything in my application. Every single line of code in my application, I'm going to wrap it with a try-catch. So I'll just take every method and I'm going to blindly just copy and paste everything in there. And that's definitely a strategy that some people take. It's a little bit lazy, quite honestly. Some developers have done that, but they're often ostracized by their end users for providing very cryptic error messages. So if we were to leave all of these off and just wrap everything and just only show the exception EX, we would just be saying, hey, there was a problem here, figure it out for yourself. That's not really advocating on the part of the user, right? We're not protecting the user. Furthermore, we might be tempted to provide some type of debugging information for ourselves as developers. Sometimes you'll see some error codes pop up that no human could be expected to understand except the guy who originally wrote the application. The reason developers do this is because sometimes they take that exact approach where they just say, hey, we're going to forget about the user, I'm just going to wrap everything in a try-catch, and it'll pop the error message to me, it'll float back to me, I'll fix the problem, and everything will be okay. But again, this catch-all is convenient to the developer, but it's really frustrating to the end user, so you shouldn't do that. You should strive to put the same amount of attention into protecting your user from having these sorts of issues and protect them from having to guess at what to do next by simply helping them fix the problem. Tell them specifically if you possibly can. If you, the developer, can fix the problem, or at least you can point the user in the right direction, then that's awesome. You should do that. But if you can't, well then at least try to identify the exact nature of the problem and then ask the user for the type of input that you would need as the developer to fix the issue. You don't want to leave your users feeling stupid that they did something wrong. You want them to feel empowered, and you want them to feel like your application is well built and it considered them whenever you were building it. So that's what makes your application polished. It's what users expect, a reliable experience with no surprises. All right. So to recap this lesson, we talked about a number of different things related to exceptions that can happen. Essentially, anytime that you, the developer, are not completely in control and you're accessing things outside of your boundary of control, outside of your domain, you need to wrap those in a try-catch and be thoughtful about the types of exceptions that you'll be handling. Listening for specific exceptions that a particular method could raise, and it's easy to find out. All you got to do is hover your mouse cursor over it, or you go to MSDN and you find that method and you look for, like we did, all the potential exceptions that could happen, and then be reasonable about it, but then write the code necessary to handle those exceptions and protect your end user. We looked at the try, the catch. We looked at catching the exception and then using certain properties of the exception, like the message property, to print out to the user what the issue was. We could also use this to log the error even send it to a centralized logging service like Application Insights that's available from Microsoft Azure to report back to the developers what the issues were. And then you can use the finally code block to clean up any connections you have to file systems, databases. You can set objects equal to null and go ahead and remove all of your references and be very explicit about that before you shut down the application. Okay, so hopefully that was helpful. This is a great lesson in building resilient applications, giving the users the kind of experience that they would expect whenever things go wrong in your apps. All right, so we'll have one or two more lessons and then we're done. We'll see you in the next lesson. Thank you. Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devu.com. In this final tutorial video in this course, we're going to discuss event-driven programming. Event-driven programming is really at the heart of Microsoft's presentation APIs, whether it be for web or Windows. And really, for that matter, it's at the heart of just about every other API in the .NET Framework class library. It is so essential that we have to spend a little bit of time here near the end talking about it, because it's that next step that'll help you graduate onto building real applications with real user interfaces beyond this course. So events allow you, the developer, to respond by handling those key moments in the life cycle of the application's execution, allowing you to write code to respond to an event being raised. All right. So up to this point in our simple console window applications that we've been building, there's really only been one event that ever gets fired off, and that is the application startup. So on application startup, the static void main is executed, so it's handling that event, I guess you could say. And this is where we write the majority of our code, and that's why it actually executes whenever we run the application. Now, in a modern user interface, whether it be for Windows or for web, users can interact with the various elements that they see on their screen. So they can hover their mouse cursor over given things like buttons or graphics or text boxes, and they can see maybe a change in the visual presentation. Maybe they see a pop-up that explains the usage of that given item. Perhaps they can click on an item to enact some business functionality inside the application. They can press keys on the keyboard to make things happen. They can type inside of text fields, or they can drag and drop items around the user interface. And each of those will raise a number of events. So as a software developer, you can decide to write code that responds to those interactions between the end user and those various user interface elements on screen. And you can also choose to ignore those that really don't make sense, that you really don't care about, you don't implement for your application. So a given component, let's say a button, for example, in its development by Microsoft, they included or defined an event. Let's say it's the click event for that button. Now, the developer, you and I, we say, hey, I want to write code that performs this business logic that I'm writing here in C# whenever that event, the button's click event, is raised. Then I want this code that I write to be executed. So the developer creates a method and attaches that method to the event, and I'll show you how we do that in just a little bit here. So as the application is running, the user is interacting with the application. Eventually they click that button. The .NET Framework runtime says, okay, if you were listening for the button click event, here it is. It just happened. And it will notify every one of the methods that you and I as developers have attached to that specific event notification, all right, that we've registered to that event. And I'm going to show how events are used in a simple Windows application near the end of this video in a more realistic scenario. But first, I want to start with the absolute basics and keep things as clean as possible. So we're going to work purely in a console window application. And we're going to work with a timer class, a timer object, and it has one event, which is elapse. So we can say after a certain amount of time, we want you, timer object, to execute or to raise an elapsed event, and then we're going to attach our code, our event handler code, to that event so that it gets executed every time that event is raised. All right, so maybe it'd be easier to see this in action than explain it. There are a number of different timer classes inside of the .NET Framework class library. We want to make sure we get the right one. So I want to work with system.timers.timer, okay? And I don't want to use that long name every single time. So I'm just going to add that to my using statements up here at the top, like so. And I'm going to say timer my timer equals new timer. And one of the overloaded versions of the constructor for this timer class allows us to pass in the interval in milliseconds. So every, let's say, 2,000 milliseconds, we want the elapsed event to fire, to be raised. All right, so 2,000 milliseconds would be simply 2 seconds. All right, which is an eternity as far as a computer is concerned. Okay. Next up, what we're going to want to do is say, all right, my timer, we know that it will raise an event called elapsed. And so we want to create an event handler, a method that will be executed whenever the elapsed event is raised by the .NET Framework runtime. So here you can see that we get this little message on screen that says press tab to insert, and I press tab, and it automatically creates the method stub called myTimerElapsed. So, and it creates it in a very specific way with a very specific method signature, and it also gives us this little stubbed out, hey, don't forget you did not implement me, so throw new exception, not implemented exception. Let's go ahead and remove that for the moment. But notice what happened here as well. So we are attaching or registering an event called myTimerElapsed to the elapsed event. So this references this code block right here. Okay, and so inside of here we can write the code that we want to execute each and every time the elapsed event is triggered inside of our application. So this is where I might write something like a console dot writeLine, and the elapsed event will send along some event arguments, and one of the interesting event arguments is actually the signal time, and that will give me the exact down to the millisecond when that particular event was erased. Okay, so here we go, and I'll just go, actually let's do it this way so that we can format it nicely. We'll call this elapsed, and then hour, minute, second dot FFF. That should give us down to milliseconds. Okay. And now what we'll do is actually tell the timer to start ticking by calling the start method, and then we're going to go console.readLine, and we're going to say continue running until somebody hits the enter key on the keyboard. Okay. Hopefully that makes sense. And let's run the application. And now we see every 2 seconds we get this message. So you can see at 32, 34 seconds, 36 seconds, 38 seconds, plus some 1,000 milliseconds there, we get that myTimerElapsed method executing. All right. Now let's do this. Let's say that we want more than one event handler to execute whenever the event is raised. So I can do this all day long. I can say, hey, well, let's go ahead and add another method. This time it'll be called myTimerElapsed1. Notice the 1. Here I'm going to get rid of this little box again. And inside of this new method, I can do essentially the same thing. and I'll just use that elapsed 1 versus elapsed. In fact, just to make this obvious, I'm going to use that little trick we learned just a lesson or two ago, where we set the foreground color equal to the console color dot red. So that will be for the second one, and then we'll do console dot foreground color equals console color dot white. All right, so we can see clearly the two different event handlers that are both executing whenever the elapsed event is raised by our timer. So let's run the application. All right, and now we see the pair running every 2 seconds. All right, and we could continue adding additional event handlers to the event. All right, so that's what this little operator is doing. It's saying how many current items are subscribing or have been attached to this event. I want you to attach this other one too. Okay. Now we can do the opposite as well. In fact, let's go console dot write line, and we'll say press enter to remove the red event. All right, probably a better way to say that, but hopefully you get the idea. And so then after this read line, we'll add another read line for the very end of the application. And in between, what we'll do is actually unregister, detach this second event handler for this event. So we'll just do the reverse. My timer dot elapsed minus equals my timer elapsed 1. So now we have removed it, and it should no longer execute whenever the elapsed event is raised. So let's run the application. All right, so you can see, here we go. And now I'm going to hit the enter key on the keyboard, and we should only see the white, the first version of our event handler firing every 2 seconds. Okay? Hopefully that all makes sense. All right, so this is the most simple scenario that I could think up without having to actually create a real application. And by real application, I mean one with a graphical user interface. But now that we've broached that topic, let's go ahead and build an example WPF application. WPF stands for Windows Presentation Foundation. It's one of the APIs inside of the .NET Framework class library that you use to build Windows applications. In other words, applications that are executed on the Windows desktop, not web pages that are executed on a server and their markup is delivered into a browser, but a true application that's running on the end user's desktop. So I'm going to go File, New Project, and here I want to make sure to choose WPF application. It should be one of the templates that are installed in the New Project dialog. And what I'm going to call this is WPF Events, like so. All right, and then click OK. And this is not going to be a tutorial on how to create Windows presentation, application, interfaces, or how to work with it, but I just want to show you the basics are generally the same. So here we have a basic application. We can actually run the application. It'll do nothing at all. We just get a white form on screen. But I want to go to my toolbox over here on the left-hand side. I'll even pin it down briefly. And then inside of here, what I'm going to go is to this rolled up area called Common WPF Controls. Now, what you see on screen might be a little bit different than what I see on my screen. Okay, just make sure you're working inside of this main window.xaml and that you see some visual representation of your form here in the main area. All right, you could ignore everything below. That's the actual markup that will generate what you see visually here. We're only going to work with the visual editor, but know that there's some markup that's going on to produce this, okay? But again, that's a topic for another day. I'm going to drag and drop a button onto the design surface like so. I'm going to go over here to the Properties window on the right-hand side. And this will allow me to set various attributes of that object, that visual object. So for example, I can change the content to click me, all right, like so. I'm also going to add a label control. I'm going to drag and drop it anywhere on this design surface. I'm going to remove the content completely, but I'm going to change the name to my label, like so. Okay? Now what I want to do is print out the phrase hello world whenever somebody clicks the click me button. I'm going to choose the click me button, again by selecting it here in the visual editor, and then I'm going to look for this little lightning bolt over here in the properties window and click the lightning bolt, and this will show me a list of all of the events that this single control, this button can raise. Now a lot of these are going to be for very specific situations and we can ignore the vast majority of these, but the most important one here at the top is the click event. Now I can write C# code that will execute as a result of this click event being raised by the .NET Framework because somebody, the user, clicked on that click me button. So I'm just going to double click here in this white area, and when I double clicked in the white area, it created this button click method stub. Alright, so this is going to be my event handler code. Let me use the auto hide pin to get rid of that so I can see this. And here what I'm going to do is type in my label dot content equals hello world, like so. And then I'm going to save my work, and then I'm going to start the application by running it. I'm going to click the click me button, and it displays the word hello world inside of the little label. All right. Now, what you didn't realize is that maybe that whenever we double clicked inside of Visual Studio in this little white area right here, it created a event handler for us, and it wired up or attached or registered that event to this button. You might wonder, well, where is the code that looks something like button dot click plus equals, where's that code at? Well, that's a little bit difficult to describe. If you take a look at this markup code here at the bottom and we scroll all the way to the right, that is essentially what happens right here. This code will get converted into C# at the point of compilation, and it will create that little snippet that we were used to looking at in the previous code example. However, I can create a second event handler in C# by doing this. Let's go to the toolbox, and I'm going to actually grab another label and just plop it down anywhere. And I'm going to select that label and then go to the properties window, and I'll change this to be named my other label. And then I want to change the actual content of that label to be blank as well. Alright, so now what I want to do then is go to the main window.xaml.cs, and here I'm going to go button underscore dot click plus equals, and I'm going to click the, and I could click tab to insert, but I'm not going to do that. I'm going to name this manually myself. Button my other click, like so, and then I'm going to hit enter on the keyboard, or actually I'm going to hit that. And now I'm going to, you can see that I get a red squiggly line. I'm going to put my mouse cursor on that line and hit control period, and then choose generate the method button underscore my other click, and it does it for me. And you'll see something that looks very familiar here, a method stub with the not implemented exception. And here I'm going to say my other label dot content equals hello again, like so. Alright, so now if I did this correctly, whenever my user clicks the button, it will not only fire off this event handler, but then also this event handler. And this event handler we wired up manually using the technique that we learned in the previous code example. So let's just run it and make sure this actually works. and it does. All right. So the same principles are at play here. The difference is the vast number of events that are accessible to every single visual control in your toolbox whenever you're working with the Windows Presentation Foundation API. All right. All right, so the main takeaway of this lesson is that events are all around us, and especially whenever working with Windows and web applications, we're going to write our code in methods that respond to specific events that are raised by the .NET Framework runtime in response to events that are published by the various objects inside of our Windows apps, our web apps, and so on. Okay, and we can either rely on Visual Studio to wire things up for us in a very quick and elegant way, like we saw here in our XAML code, where we let it essentially do the wiring for us, or we can take control of that process of wiring, of attaching, of registering an event handler to a specific event, and then write the code ourselves to actually respond to that event being raised. Okay, so again, extremely important. Hopefully that's the next logical step for you, is to move on to other APIs, whether it be something like ASP.NET or WPF, like we've worked with a little bit right here, or the Universal Windows Platform to build Windows Store applications. And you'll need to know these concepts for all of those. And that pretty much wraps up this lesson, and this entire course. We'll have a couple of closing comments in the next video, and then that's it. So we'll see you there. Thanks.